let us see what will happen if a bar magnet is kept in a magnetic field. Here there is a magnet, then there is a magnetic field. Magnetic field is from north pole to south pole, so there is a magnetic field as shown by this arrow. Here a bar magnet is kept at an angle theta with the field. So this is the direction of the field. It will experience a torque. Now let us see. It's a north pole. So north pole will experience a force in the direction of the field. So magnetic pole strength of this is Qm. Then force experienced by this north pole is Qm B vector. B vector is the magnetic field. Magnetic field, intensity of the magnetic field is the force experienced by unit north pole. Here strength of the pole is Qm. So Qm into B vector. That is the force experienced by north pole. Force experienced by south pole will be in the opposite direction, opposite to the field that side. So that's why here there is a negative sign. Then net force, this is a uniform magnetic field. Net force is the sum of these two, vector sum. So you can see Qm B vector minus Qm B vector. So when we add, it will be 0. So north pole will experience a force that side, south pole will experience a force this side. So two equal and opposite forces constitute a couple. Moment of the couple is known as torque. Torque is denoted by this letter tau, it's a Greek letter. Then center of the magnet is ON. So this is this is ON vector. Torque is ON vector cross F vector. The force is that side. So force is acting that side. So moment of the force ON vector cross Fn vector. Then for this south pole, here force is this side. Then OS vector cross Fs vector. Then ON cross Fn vector. Fn vector we can write Qm B vector plus OS cross Fs vector we can write minus Qm B vector. Here as per the right hand corkscrew rule, the torque is directed into the board. So this is ON vector, this is F vector. So ON cross Fn vector. ON cross Fn. So it will be directed into the board. Similarly here OS cross Fn. OS is the side. No, F is the side. OS is this side. So OS cross Fn. OS cross Fn also directed into the board. Now magnitude of ON vector will be same as magnitude of OS. ON and OS. It is L. Length of the magnet is 2L. Similarly, magnitude of Qm B vector. This is a force experienced by north pole. Then this is a force experienced by the south pole. Magnitude is equal, only the direction is different. Now for this Qm B vector, this is Qm B vector. So now instead of the vector, we consider the magnitude of the vector. So this is the magnitude of the vector torque. The magnitude of the torque is equal to, then this instead of ON vector we can write L, instead of Fn vector we can write Qm B. Then it's a cross product. So when you take the cross product, A vector cross B vector is AB sin theta. Magnitude of ON vector is L. Magnitude of Qm B vector is Qm B. Then angle between these two Vectors are theta, so it is sine theta. Then cross product is A vector cross B vector is AB sine theta. Magnitude of OM vector is L. Magnitude of this is QMB. Then sine theta. A vector cross B vector is AB sine theta. Plus OS vector. Magnitude of OS vector is L. Magnitude of QMB vector is QMB. Then sine theta. So when you add these two, it will be 2LQMB sine theta. Then QM into 2L, that is magnetic dipole moment PM. Then B sine theta. Then in vector notation, this can be written as PM vector cross B vector, because the PM vector cross B vector is PMB sine theta. So this is the torque experienced by a magnetic dipole kept in a magnetic field. Thank you for watching.